Action.
Good day, friends and students. You're welcome to yet another episode of our Prep Station UTME tutorials. And in this edition, we are going to be taking physics. And in physics, we'll just be looking at a few topics. On our list is motion. First of all, what is motion? Motion can be defined as the change in the position of an object with time. So once there is a change in the position of an object with time, we say that motion has actually taken place. Now, types of motion. Example, you have circular motion. Circular motion is when an object is moving along a circular path. When an object moves in a circle, we are said to have undergone circular motion. Random motion is the movement of an object in a disorderly manner. When there is a disorderly movement of objects, we can say that there is random motion. Translational motion is when objects move linearly on a straight line. So when object moves linearly on a straight line, for instance, when a car is traveling along a straight path, the car is said to have undergone translational motion. Rotational motion occurs when an object moves about a point in a circular path. When an object moves about a point in a circular path, that is known as rotational motion. Now, in motion, there are a few terms that we want to just look at. What are the terms that make motion possible? One of it is called speed. Speed is the rate of change of distance with time. The rate at which distance is moved with time is known as what? Speed. The SI unit for speed is meters per second. So if you want to define speed, speed is the rate at which distance is moved with respect to time. Now, what is distance? Distance is the length between two positions. Once the space between two positions can be measured, you can call it distance. The length between two positions is known as distance. Distance is measured in meters. Distance can also be calculated by multiplying speed and time together. That will also give you distance. Now, what is displacement? Displacement is distance moved in a specified or specific direction. Displacement is a vector quantity, while distance is a scalar quantity. A scalar quantity is a quantity that has only magnitude but no direction. But a vector quantity has both magnitude and direction. So the difference between distance and displacement is that distance is a scalar quantity while displacement is a vector quantity. Now, both of them can be measured in meters. For instance, if we talk about 5 kilometers northeast, that is displacement, while 5 kilometers is distance. So that is the difference between distance and displacement. Now, next we are going to be talking about velocity. Velocity is the rate of change of displacement with time. It is a vector quantity. The SI unit for velocity is meters per second. Velocity is displacement divided by time taken. Now, the next term we'll look at is called acceleration. Acceleration is the rate of change of velocity with time. Velocity and acceleration are all vector quantities. Now, what is rectilinear acceleration? That is the change in velocity with time. For instance, if a car moves from velocity A to velocity B with respect to time, we can call that rectilinear acceleration. Uniform acceleration occurs when the rate of change of velocity with time is constant. When the rate of change of velocity with time is constant, we can now call that uniform acceleration. Now, having gone through these terms that are associated with motion, the next thing we want to look at, there are equations that make motion possible. We have looked at displacement, we have looked at distance, we have looked at velocity, we have looked at acceleration. Now, basically, there are three equations for uniform motion. There are three equations of motion there are three equations for motion. The first is given as u is equals to u plus at. Now, that is the first equation of motion. The second equation is given as s is equals to ut plus half at squared. while the third equation is given as v squared is equals to u squared plus 2as. Now, let us define the terms that are present in these three equations that we have mentioned above. First of all is v. V is final velocity, and final velocity is measured in meters per second. Like we said before, velocity is a vector quantity and is the rate of change of displacement with time. Time is measured in seconds, while s is distance. S is distance, the length between 2 points, while a is acceleration, uniform acceleration or deceleration as the case may be. So those are the important terms that we need to know when we want to study motion. So having gone through all the terms that are necessary for us to understand motion, we want to just look at a few questions that deal with this topic called motion. The first question we have here is, a car moves with an initial velocity of 25 meters per second and reaches a final velocity of 45 meters per second in 10 seconds. What is the acceleration of the car? If you look at this question very well, you see that a few parameters were given to you. First of all, you were given initial velocity, then you were given final velocity, and you were given time. Now, if we consider the first equation of motion, which says that u is equals to u plus at, v is equals to u plus at. V there is the final velocity, and which is given as 45 meters per second, while u is given as 25 meters per second, which is the initial velocity. Now, if you do simple substitution with the first equation of motion, you can see that acceleration, which is a, is given as v minus u all over t. So if you put that equation into perspective, and from what you have been provided, we have u, which is 25 meters per second, v, which is 45 meters per second, and t, which is 10 seconds. So if we impute these values into our equation, we are going to see that a is equals to v minus u all over t, which is 45 minus 25 over 10, which will give you 20 divided by 10. 20 divided by 10 will be 2 meters. Now, if you go back to the question, you see that a few options were given. The first option said 5 meters per second. The second option said 25 meters per second. The third option, option C, said 25 meters per second. And then the last option, which is D, said 2 meters per second. So from here, we can see that the correct option is D, which is 2 meters per second square. Acceleration is measured in meters per second square because it is the rate of change of velocity with time. So let's look at another question, past question in physics. A car starts from rest and moves with a uniform acceleration of 30 meters per second for 20 seconds. Calculate the distance at the end of the motion. The first option A is 6 kilometers, B 12 kilometers, C 18 kilometers, D 24 kilometers. Now, if you look at this question carefully, you are given a few parameters. Number one, you are given the acceleration, which is A, and the value there is 30 meters per second, and then you are given time, which is 20 meters per second square. Now, if you run through the three equations of motion, you will see very well that it is the second equation of motion that actually fits this question perfectly, which says that s, which is distance, is equals to ut plus half at squared. Now, from this question, you will know that your initial velocity is equals to 0 because the car is moving from rest. So because of that, the initial velocity is 0 meters per second. Now the acceleration is given as 30 meters per second square, while the time is given as 20 seconds. Now if you substitute these parameters into the second equation of motion correctly, you will notice that the distance will be 0, which is the initial velocity, multiplied by the time. Then you add to half of the product of the acceleration and the time squared, which is half into bracket 30 multiplied by 20 squared. Now, if you go back to the question, you will notice that 0 times 20 will give you 0. So your distance is going to be 0 plus half the product of your acceleration multiplied by the square of the time, which is half into bracket 30 multiplied by 400. Now, half into 12,000 meters, and half of 12,000 meters is going to be what? 6,000 meters. If you go back to your options in the question, you notice that the options were given in kilometers, but meanwhile you have solved them in meters per second. So what you simply do is you convert 6,000 meters to kilometers, and that is done by dividing it by 1,000. And if you divide 6,000 by 1,000, you are going to have 6 kilometers. So the correct option here is A, which is 6 kilometers. Let us look at another question, still under motion. A body falls freely under gravity from a height of 40 meters to the top of a platform 0.8 meters above the ground. Its velocity on reaching the platform is what? So if you look at this question, you will notice that the body is falling from a particular height onto another height which is below the ground. The height from the ground to where it falls is 0.5, and the total height where it's falling is what? 40 meters. So you need to get the difference in that height, which will give you 40 minus 0.8. So the total distance in question now is going to be 39.2 meters. Now, using the third equation of motion, which states that v squared is equals to u squared plus 2as. So we notice here that v, which is your final velocity, is what we are looking for. And our initial velocity is going to be 0. And our distance here is 32.2 meters. So v squared is equal to 0 plus 2 into bracket 39.2 multiplied by 9.8, because our gravity was given at 9.8 seconds. And if you sum that up properly, you are going to have 768.32. So if you take the square root of 768.32, you are going to have 27.7 meters per second. So if you go back to your options, the option A says 784 meters per second, option B says 80 meters per second, option C says 78 meters per second, and option D says 27.7 meters per second. So the right option there is option D, which says 27.7 meters per second. So that will be the velocity on reaching the platform. Now, let's take the last question under this topic. It says a bullet fired vertically upwards from a gun held 2 meters above the ground reaches its maximum height in 4 seconds. Calculate the initial velocity, taking your acceleration due to gravity to be 10 meters per second. Now, with respect to the 3 equations that I give it, anytime the motion of an object is against gravity, the 3 equations are still usable, only that we are going to change the positive sign in between those equations to become negative, since the motion of the object is going against gravity. So the g there is going to be negative. So if we take our first equation, which says v is equals to u plus 80, we are now going to replace it. The v is equals to u minus, instead of a, now we replace it with g and multiply by t. And the reason is because we say that the stone is going against gravity, and because of that, the g will take a negative sign. So our v, which is our final velocity, is obviously 0, and then our initial velocity is what we are looking for, and then we have 10, which is our acceleration due to gravity, and multiply by 10 by the time, which is 4 seconds. So we have 0 is equals to u minus 10 multiplied by 40, and if you do that properly, you are going to have your answer as 40, which will give you 40 meters per second. And so the option which is correct there is option C, which is 40 meters per second. Friends, we will come back. Let's have a break.